Hello everyone, welcome to another session of nanomaterials. As part of our lecture series on nanomaterials, we have discussed different topics and we have compared the top to down approach and the bottom up approach, and we discussed about the importance of synthesis method on changing the properties of nanomaterials and what is the size impact on the properties. These parts we already covered in different videos. Coming to the synthesis point of view, in what way we are following the methodology in making the material, in what way we are following in the preparation of nanomaterials is most important, especially to control or to optimize the properties of nanomaterials. Based on my experience from the last 10 to 15 years working on nanomaterials, here I am going to discuss about the preparation of nanomaterials by using the ball mill method. Ball and mill. Here, whatever you are assuming like a ball, the same ball, but it's not like a cricket ball, right? It's like a steel balls with high dents, and we are considering the balls is like a steel or zirconia high quality balls, because iron balls some cases it may rust, it can form the rust on the surfaces that may mix with the nanomaterials, so that may impact the properties of nanomaterials. Because of this, most of the cases we are using the steel balls. And the grinding medium, milling is like it is operated by machine. It's like machine. So just imagine the kitchen like mixie. So we are using mixie, right, to crush the powders. What we will do here, we are taking the blade. In case of mixie point of view, we are taking the blade, but here in case of barley milling method, we are not taking any kind of blade. So in case of like a kitchen mixie point of view, we'll take the blade and it cut down into the smaller particles. While rotating, it cut down the smaller particles in a rapid manner. But whereas in case of ball milling method, here also we have rotating chamber. Here also drum, it called as drum. It also having like rotating chamber. Within that chamber, the balls are placed. Just imagine the chamber is closed, but inside the chamber there are different balls, even different sizes. I will explain why the different sizes of balls are considered. So just imagine it is rotating. How the balls are moving? It may move till that particular place. On the top, it may drop because of gravity. And again, it may travel with the drum, and once it reach to the height and drop to the bottom because of the gravity. As discussed, these balls are very dense. Once it drop to the down, it impact the lower surface. This is the principle involved in cutting down the particles in ball milling method. But in the grinding medium, in addition to the balls, we are placing the material what we need to cut down into the nanostructures. So within the drum, some portion is related to the material what we want to cut down, and remaining portion is like a balls. This is also one of the most important ball to mass ratio, mass to ball ratio. That means how much quantity we are taken to cut down into the nanostructure, how many balls we are placing in the chamber. Generally, like a ball to mass ratio should be very high. That means most of the 70-80% related to the balls and 20% related to the powder. Then only there is a possibility to cut down in easy way. And here, as discussed in the last sentences, here we are using the different balls. Like for example, 1 centimeter, 5 mm, 1 mm, etc. Because, for example, just imagine 4 balls are placed. There is a gap in between these two. In between, there is a gap once you place 4 balls side by side. So there is a possibility of escape the powders in that gap while rotating. So to avoid that particular things, so we are just taking these small balls also. So that is mean that there is no possibility to escape in any manner. That is, there is no gap takes place in the chamber in between the balls. So then obviously once it is moving up and down, down, there is a powder what we want to cut down. So it impact the down surface. So because of this, there is a possibility to mill the powders. So here RPM is the another word, rotation per minute. We are giving the RPM, like how many rotations that takes place per minute. So generally mostly we are using like a 400 or the 500 RPM. And time of hours is also another important. Time of hours means some cases we may require like a 4 hours, the 5 hours, 6 hours, depends upon the initial size of the raw material. If the initial raw material size is more, it may take like more hours to cut down into the required size. So here in case of ball mill method, the impact is the collision. Ball to mass ratio is one of the important parameter. The milling time is another important parameter. Mill power is also another important, and RPM, these parameters are most important, need to be considered in the process of milling, like a ball milling method. Here, so once if it is rotating like this, there is a possibility of stick on the walls of the chamber. For this, we generally use the zirconia chamber or agate chamber to avoid the stiffness occur inside the like a milling chamber. And power also takes a big role. How much it can able to rotate, how much impact it can able to create on the powders. That is high fast, ultra fast ball mills or low ball mills. So in case of ultra fast ball mills, it has very high power. It can able to move with high power. It can able to move. Because of that, the crushing can takes place in easy manner. So, and ball milling, like a mixing method, in case of ball milling, there are two ways we can grind. One is like a dry grinding and another is the wet grinding. So like grinder, like a without water and with water. Here that might be water or ethanol or methanol. There is a solution we are adding to the grinding media so that easily it can, without escaping the powder particles, it can easily grind. So based on the media nature, whether it is wet or dry, again the grinding methods are classified into the wet grinding or raw grinding, like a dry grinding. So this is one of the easiest technique to prepare the bulk materials, but the problem is inhomogeneity takes place in the process of making the nano powders, and it is like a instrument is required, obviously little bit costly, and more hours are required to cut down the particles into the nanostructures. And mechanical method, and the noise is occur, like once it is rotating, keep on rotating, duck, that kind of sound it will appear. Then obviously in case of ball mill method, noise is occur. Inhomogeneity is one of the bigger tasks to control the in ball milling method. This is my experience, what I observed in the preparation of different nanostructures using the ball milling method. Again recap. So in case of ball milling method, impact is the collision. Chamber might be like a gate or a steel, or based on the cost. So the chamber might be like a gate chamber or zirconia chamber or like a steel chamber, etc., to avoid the stiffness of the powders in the medium. So ball to mass ratio is most important parameter. Milling time and the milling power and the milling RPM is play a big role in creating the nanostructures. And here it is the mechanical method or the physical method, and more milling time is required. There is inhomogeneity takes place in the preparation of nanomaterials. And last one is the noise may give the one of the bigger issue in case of nanomaterial synthesis. Thank you. Hope you have some idea related to the mechanical method. I'm not using any diagram, just I'm sharing my knowledge or the experience to the audience. So definitely I will share some like a image files. I will use some like a animation content whenever it is required. I hope it is not required in this aspect. Definitely for your point of view, I will share some of one or two images in the last. Hope you enjoy my content. If you really like or if you feel it is really useful, please support me in the form of subscription. Subscribe the channel. Thank you.